Hi everybody and welcome back to my channel. In today's video we are going to be talking about the powers of binomials using the binomial theorem. So the formula for the binomial theorem is a plus b to the power of n. So if we want to expand a binomial which is two terms, in this case is a plus b to the power of n, we find the summation of n choose r multiplied by a to the power of n minus r multiplied by b to the power of r, where r changes from 0 until it becomes n. So expanding this formula gives us n choose 0 because r starts from 0. So n choose 0 multiplied by a to the power of n minus r, and our r is 0, so it will be a to the power n minus 0 multiplied by b to the power of 0 plus n choose 1 multiplied by a to the power of n minus 1 multiplied by b to the power of 1 plus n choose 2 multiplied by a to the power of n minus 2 multiplied by b to the power of 2, and so forth until we get to n choose n multiplied by a to the power of n minus n. Of course this will be a to the power 0 multiplied by b to the power of n. So let's look at our first example and see how this binomial theorem works. Looking at our first example, we are given expand 2x plus 3 in brackets to the power of 4. So let's first identify our n, our a and our b, and plug everything into our binomial theorem formula. So our formula says it's n choose r multiplied by a to the power n minus r multiplied by b to the power r, this being a summation where r starts from 0 until r becomes n. So we can rewrite this using the given variables now, using the given information. So our n, we need to identify our n will be the given exponent. So in this case our n is 4, and our a will be the first term inside the bracket, which is 2x, and our b will be the second term inside the brackets, which is 3. And r is going to change, so our r is going to change from 0, it goes to 1, it goes to 2, it goes to 3, and lastly it goes to the given exponent, which in this case is 4. So this can be written, I'll write it down here, this can be written as the summation from r is equal to 0 until n is 4 of what? N, so it will be n choose r multiplied by a to the power of n minus r, so it will be our n choose our r multiplied by a, and our a is 2x, so multiplied by 2x to the power n minus r multiplied by b, which is 3 to the power of r. Now all we need to do is to replace the values of r as we carry on. So let's do that. So expanding this, our first term will be n choose r. Remember our n is 4 and our n does not change. Our n remains 4. What only changes is the value of r. So it's going to be 4 choose 0 multiplied by our a, which is 2x, let's put it in brackets, to the power of our n is 4 minus 0, because r is starting from 0, being multiplied by 3 to the power of r, and my r in the first term is 0. So this is our first term, plus the next one will be 4. Choose. Now my r is 1 multiplied by 2x to the power 4 minus 1 multiplied by 3 to the power of 1. Then we move on to the third term, which will be 4 choose 2 multiplied by 2x to the power of n minus 2, which is 4 minus 2 multiplied by 3 to the power of 2. Moving on to the next term, it will be 4 choose 3 multiplied by 2x to the power of 4 minus 3 being multiplied by 3 to the power of 3. And our last term will be 4 choose 4 being multiplied by 2x to the power 4 minus 4 multiplied by 3 to the power of 4. Now let's try to simplify this and see what it gives us. So you go to your calculator and you punch in 4 choose 0. So you press 4, you press shift, and you press the division sign. It will give you a C. So 4 choose 0, that's a 1. So this part here is 1 being multiplied by 2x to the power 4 minus 0, that's just 2x to the power 4. So 2 to the power 4, that's 16 x to the power of 4 being multiplied by 3 to the power 0, which is 1. The next term will be 4 choose 1. So let's take our calculator, shift, division sign, 1. 4 choose 1, that's 4. So it will be 4 being multiplied by 2x to the power 4 minus 1, that's 3. So 2 to the power 3, that's 8 being multiplied by x to the power of 3 being multiplied by 3 to the power of 1, which is just 3. Let's move to the next term, which is this one, 4 choose 2. Again, we're going to say 4 shift division sign 2. This gives us 6. So 4 choose 2, that's 6 being multiplied by 2x to the power 4 minus 2. 4 minus 2 is 2. So 2 to the power 2, that's 4 x to the power x to the power 2 being multiplied by 3 to the power 2, which is 9, plus the next term will be this one, 4 choose 3. So we go back to our calculator. 4 choose 3 is 4. So 4 choose 3, that's 4 being multiplied by 2x to the power 4 minus 3, that's just 1. So this remains 2x being multiplied by 3 to the power 3, which is 27. And lastly, we have 4 choose 4. So back to our calculator. 4 choose 4 is 1. So it's going to be 1 being multiplied by 2x to the power 4 minus 4, that's 0. So 2x to the power 0 gives us 1 multiplied by 3 to the power 4, which is 81. Now let's simplify this to get our final answer. Now simplifying this, the first term will be 1 multiplied by 16 multiplied by 1, that's 16 x to the power of 4, followed by, so we have a plus sign, 4 multiplied by 8 multiplied by 3. So 4 multiplied by 8, that's 32, multiplied by 3, that's 96. So plus 96 x to the power of 3. followed by 6 multiplied by 4 multiplied by 9. 6 multiplied by 4, that's 24, multiplied by 9, that's 216. So plus 216x to the power of 2 plus 4 multiplied by 2, that's 8. 8 multiplied by 27. So 8 multiplied by 27, that's again 216x. And lastly, we have 1 multiplied by 1 multiplied by 81, which is just 81, which makes this to be our final answer to example number 1. 16x to the 4 plus 96x to the 3 plus 216x to the 2 plus 216x, and lastly plus 81. So this is the answer to 2x plus 3 in brackets to the power of 4. Now let's look at our second example, where we are given a question which reads, find the coefficient of the x to the 7, y to the 3 term in the expansion of 3x plus 5y to the power of 10. So in this particular case, we don't have to expand the whole of this binomial expansion. We don't have to expand the whole of the binomial expansion. In this case, we just have to find one term with x to the power 7 and y to the power of 3. So the first thing that we need to do in this case is to identify the value of r, because we know that our r goes from 0 until 10. So if we check here, we have two terms inside the brackets. The term on the right side is the one with the y, which is also the one on the right side here. We have y to the power 3 on the right side. So this implies that the exponent of this same variable on the right side is the value of r. So the exponent of y, which is 3, becomes our r. So we know that our r has to be 3. So we can go into our binomial theorem and replace r with 3. So we know that according to the binomial theorem, it's n choose r multiplied by a to the power n minus r multiplied by b to the power of r. So let's also identify our a and b. So in this case, our a is 3x and our b is 5y, and my r, like I said, will be the exponent of the term on the right side, which is our y. So the exponent of this variable here, y, is 3. This should be our value for r. Now let's plug in these values into this formula here. So our n, and our n is 10. So our n is the given exponent here. Our n is 10. So we are going to have 10 choose our r is 3 being multiplied by a, which is 3x, all raised to the power of n minus r, so to the power 10 minus 3, being multiplied by my b, which in this case is 5y, raised to the power of r, which is 3. So this should give us the answer that we want. So this is the same as saying 10 choose 3 multiplied by 3x to the power 10 minus 3, that's 7, being multiplied by 5y to the power of 3. And let's take our calculator and find the value of 10 choose 3. So shift division sign 3. 10 choose 3, that's 120. So we have 120 being multiplied by 3 to the power of 7 and x to the power of 7. So what's 3 to the power of 7? So 3 to the power of 7 gives us 2187. So multiplied by 2187 multiplied by x to the power 7 and multiplied by 5 to the power of 3. 5 to the power of 3, let's take our calculator. 5 to the power of 3, that's 125. So this is being multiplied by 125 y to the power of 3. Now simplifying the constants here, we are going to get 120 multiplied by 2187 multiplied by 125 to give us a very big number, 328 05 00 with another 0. So 328 05 000. 32,805,000 together with x to the power 7 and y to the power of 3. So if we go back to the question only wanted us to find the coefficient of the term with x to the power 7 and y to the power 3. And the coefficient that we found is 32,805,000. So this becomes our answer. So the coefficient only is the constant here, 328 05 000. So that's it for example number 2. In example number 3, we are given a question which says find the coefficient of the xy to the power 6 term in the expansion of x plus 2y in brackets to the power of 7. So the first thing is to identify the values of n, r, a, and b. So again, in this case, we know that our binomial theorem says is n choose r multiplied by a to the power n minus r multiplied by b to the power of r. So our n, in this example, our n is the given exponent, which is 7. Our a is the first term inside the brackets, which is x. Our b will be the second term inside the brackets, which is positive 2y. And our r will be the exponent of the term on the right side, of the variable on the right side in the given question. So we have y to the power 6. So our r is to be 6. Now let's plug these ones into our binomial theorem formula. So it's going to be n, which is 7, choose 6, multiplied by our a, in this case is x, to the power of n minus r, and our n is 7 minus our r is 6, multiplied by b, our b is 2y, all raised to the power of r, and our r is 6. And let's simplify this. Let's go to our calculator. 7 choose 6 is 7. So this will be 7 being multiplied by x to the power 7 minus 6, which is just 1. So multiplied by x, multiplied by 2 to the power 6, multiplied with y. So 2 to the power of 6 is 64. So multiplied by 64 with y to the power of 6. And multiplying 7 with 64, 7 multiplied by 64 will give us 448. So this is 448 x with y to the power of 6, which implies that the coefficient which they are asking about of x y to the power 6, the coefficient will be 448. So this is our answer to example number 3. Let's move on to example number 4, in which we are given a question which says find the coefficient of the fourth term in the expansion of a plus b to the power of 12. So in this case, they want us to find the coefficient of the fourth term in the expansion of a plus b to the power of 12. So what we need to know is our value for r. So remember our r starts from 0. So when r is 0, it is the first term. When r is 1, it is the second term, which means that for us to get the fourth term, r will be 3. So this implies that our r is 3. Our r here will be 1 less the position they are talking about. So they are talking about the fourth position, r will be 3. And our a is just a, and our b is b, and our n is 12. And our formula says n choose r multiplied by a to the power n minus r multiplied by b to the power of r. So when r is 3, it will be 12 choose 3 multiplied by a to the power of 12 minus 3 multiplied by b to the power of my r is 3, which will be, let's go to our calculator. 12 choose 3 gives us 220. So this is 220 being multiplied by a to the power of 12 minus 3, that's 9, multiplied by b to the power of 3. So according to the question, all they want is the coefficient of the fourth term. So our coefficient will be 220. And the whole term of the fourth term will be 220, a to the power 9, b to the power of 3. Moving on to example number 5, we're given find the ninth term in the expansion of 4x minus 2y to the power of 12. So we need to find the ninth term. So step number 1 is to identify our r. Since we are finding the ninth term, and our r, since it starts from 0, it implies when we get to the ninth term, r will be 8. It's always 1 less the given position they want you to find. And our a is 4x, our b is negative 2y, and our n is the given exponent, which is 12. And we know that our formula, our binomial theorem, is n choose r multiplied by a to the power n minus r multiplied by b to the power of r. Now let's replace the values of a, b, n, and r with the ones that we took from this question here. So we want the ninth term, it will be 12. Choose when r is 8 multiplied by, so it will be 12 choose 8 multiplied by a. Our a is 4x to the power of n minus r. Our n is 12, our r is 8 being multiplied by b. Our b is negative 2y being raised to the power of r, and our r is 8. Now simplifying this, let's go to our calculator. 12 choose 8 is 495. So this is 495 being multiplied by 4x raised to the power of 12 minus 8, that's 4, being multiplied by negative 2y to the power 8. Now let's simplify this part here. So this is 495 being multiplied by 4 to the power of 4. So 4 to the power of 4 is 256. So being multiplied by 256 multiplied by x to the power 4 multiplied by negative 2 to the power 8. So let's put our negative 2 in brackets. To the power of 8 is also 256. So positive 256 with y to the power of 8. Now let's write our simplified answer. Let's multiply 495. This 495 multiplied by 256 multiplied by another 256, which gives us 32440,320. So 32440,320 multiplied by x to the power 4 and multiplied by y to the power of 8. So 32,440,320 x to the power 4 and y to the power of 8. This becomes the 9th term in the expansion of 4x minus 2y to the power of 12. That's it for example number 5.